quickly to make sure that that's working. That's weird. There we go. Okay, it is working. Lovely, lovely, lovely. And we'll just do a quick tweet. Person, code review, fun times. Okay. So today we're going to do a quick look at sort of some changes and refactoring that's to help support Spark doing better directory listings. And you might think that this is kind of a little weird, and I'll admit, when you think of a distributed system, oh, fuck. Damn it, I dropped a screwdriver in a glass of water. That didn't go, or not screwdriver, fuck, okay. I was going to talk about a thing, but then I got distracted by my own clumsiness. I have rescued the little mini wrench. Although my hands are kind of... just... anyways. Before I got distracted and dropped the thing in the thing. Right, okay, directory listings. So, directory listings seem kind of innocuous, but with Spark, and other systems like it, you'll often be in a situation where you need to list hundreds of thousands of files. And this is especially true for people that have structured their data, in certain ways to normally minimize queries. But in practice, when you need to do the full table scan, it's not a party. So, with that being said, let's go ahead and start digging in. This is PR by a coworker, I think. Yeah. Okay, cool. And so, you can see that this used to have a different title. Back in the day, it was a work in progress PR. It's no longer work in progress. So it's probably time for me to review. Oh, cool. This is pretty cool. That is really rockin'. That is really cool. So, with that being said, let's go ahead and jump over into Files Changed and start taking a look at the code. So, yeah, let's take a look. Okay. So this is the Hadoop FSutils, this is mostly code that is moved from somewhere else in the project. So it's not all new code. We'll see the deleted code in a little bit, but I'm gonna just go through this really quickly. Yeah, okay. Yep. And so ignore locality, and this one's surprisingly important, and that is because, getting locality information can be really expensive in some situations. Okay, the parallel listing threshold, this is also important. So sequentially listing, hundreds of thousand files in a single thread. Obviously, that could be a little bit slower than we might want, or maybe not obviously. That could be a little bit slower than we want. And since Spark has parallel and distributed primitives inside of it anyways, we might as well parallelize the work when it makes sense. But on the other hand, if someone's got like a thing with 5 files, starting a Spark job to list the files, that's going to actually make things slower. And that's why there's this threshold, which we use to determine when we want to cut over to doing parallel listing. Maximum parallelism. Yeah. Filter function, optional predicate on the leaf files. Files who fail to check will be excluded from the results. Return for each input path. This is discovered files for the path. Yep. So that looks good. Right. And so what this does is even when we call parallel list, if we're below the parallel listing threshold, we go into the list_leaf files, and list_leaf files is, where is it? It's down here. And this is the non-parallel version. So let's go back up here, take a look. This looks fine. Yeah. Yeah. So there's this thing where it's like, hey, incremental parallelist. So we're calling Hive catalog metrics, and we're doing that even though this, I'm gonna make this window a little bit so it fits. There we go. We're calling this increment parallel listing job count, and so we're just keeping track of when we're parallelizing and not. Ooh, sorry, I forgot that I need to. And so this is, you know, I said like, hey, we could do a callback here maybe, and then another committer suggested, well, what about if we just called this in the SQL side before we come down here? And then I pointed out why that wouldn't work, and they're like, okay, cool, callback sounds good, we'll do later. Yep, sounds good to me. File Jira for switching this to a callback. And so that's just the like making sure we don't forget it. Right, okay, this is the thing. We don't start more parallelism than the number of paths we have, but we also don't start more parallelism than the maximum configured parallelism. This thing is a little funky, and it's one of these things where so what's happening here is it's getting the previous job description, and then it's writing a new job description, and then we're going to restore the previous job description. And honestly, I don't super understand. Well, I guess I do. It's just, I wish our job descriptions were handled a little bit better and we didn't have to do this, but it is what it is. Okay, and then here we go. Inside of the parallel, you see we use the non-parallel listing. And since in Spark we have this limitation where Spark jobs can only be started on the driver, we don't pass in a Spark context to any of the workers so that the workers don't try and start a job and fail. And actually the Spark context isn't serializable, so it fail anyways. The result that we get back, we turn into serializable block locations. Okay. And that's because the block locations are not serializable to be sent over the wire. Interesting. This is off. I also shared Sunchao's view that like great to do in a follow-up as well, but I thought that because file status and path is serializable, that all of the subclasses would be, but it sounds like that's not the case. Today I learned. Thanks for the context. Oh, well, okay. He's got a thing that says busy when I go to autocomplete his name, so I won't mention him so he doesn't. I'll just do this. Okay. And yeah, so this is turning the serializable things back into the regular objects. I wish there was an easy way to do this. Yeah. Ah, here we go. Here we go. Okay, this is a part that I'm interested about. So distributed file system overrides list located status to make one single call to the name node to retrieve status and block location, blah, 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 blah. It's much better to use the incremental list located status for better performance. Yeah, HDFS. Oof. Oh, this is getting intense. Okay. Okay. Interesting. Oh, what's this PR? Oh, that's the IO statistics PR. Yeah. Yeah, so here we could add just more file systems to the type, but I agree that we should use it everywhere, but I also think that it shouldn't be blocked. Okay, and then we've got the ignore locality, and the ignore locality. Oh no, sorry, this is if not ignore locality. It's fine. Okay, our root paths was changed to is root level. I don't have strong feelings here. Why are we importing Hadoop FS utils now? Oh right, yes, sorry. That's the new thing, right? And so this is the code that was refactored is copied over. With many small changes. Okay, so I'm gonna go ahead. Let's go look at this conversation. There's 85 comments. That's a lot. That's a lot more comments than I was sort of expecting. Yeah, so I'm gonna go ahead, and what I'm gonna do is I'm gonna say, looks good to me from a pure refactoring point of view. Looks good to me. Looks good to me. If no one objects, I'll merge this on Monday, so we can unblock the follow-on work that the conversation seems to follow-on work that folks seem interested in. There we go. And let's double check. Yeah, all tests are passing. This looks fine. Let's hit approve, and there we go. And that's just like there's legitimate things, but I think we should address them in a separate PR. So let's take a look. I think there was a second PR here, but I could be wrong. So if there isn't, we'll just go and find something random. I think there was a these are both SQL PRs. I thought it was gonna also be about listing. Okay. those are let's take a look. What is this? Yeah, okay. Really not my strong suit over in the SQL world. So before we wrap, because this one's a fairly short one, let's talk a bit about why this refactoring is happening. So the existing parallel listing and non-location sensitive listing in Spark is implemented exclusively for Spark SQL. And so what this does is this takes that Spark SQL code and it moves it to core. And as you can see in these discussions, there are other improvements that we can make to how SQL's been doing it to take advantage of some of the improvements in the Hadoop file system layer below us. Or, well, not just the Hadoop file system layer, but the Hadoop compatible file systems. And one of them has written a fabulous post, it looks like, about different ways to get the most performance out of listing files from the Hadoop file system. And so this is really wonderful. I'm really excited for the follow-on PR to this PR, and that's going to be essentially, this is the PR to refactor it so that we can use this code in core. And then the next piece that I'm looking forward to is when this code that is now going to be shared between core and SQL is refactored to take some of these best practices and speed up both core and SQL. And so it doesn't look like there's any questions today, so we're just going to go ahead and we're gonna wrap with that. Thanks for joining me on Thursday afternoon. Where's Timbit? Oh dear. Okay, well, the dog is somewhere in the house. I thought he was underneath my chair, but he is not. So I'm gonna go find him and make sure he is not chewing on the wall. Thanks for joining. Bye.